Hey, good morning. Today we're starting a new section here. We just took a test last week and hopefully you did well on that. That was a lot, all that. Inequalities and absolute values and compound inequalities. That was a lot to remember, but you're going to see that we're going to use those inequalities today. So you got to kind of understand how inequalities are read. You're not going to have to necessarily know how to do the math and the multiple steps to get the variable by itself, but we will be writing today domains and ranges using inequality signs. And so it's a good lead in today. We're going to do a lot today, a lot of notes. And so buckle up. Most of this should be review because my 8th graders are learning this right now and they're doing really well. And so as we're going through domain and range, there's a couple of specific rules that you got to pay attention to on how you record your answers. But that's our job today, is that we're going to review how to find domains and ranges of linear and quadratic equations, and we're going to decide if it's a function or not. And I think a lot of this will come back to you that, yeah, you remember this, okay? First of all, we got to know some really basic things. That this is a plane. That is divided up into four parts, four regions. And parts of the plane is number one, the x and the y axis here. This is always the x-axis. In 9th grade, they usually don't label this anymore. You've done it enough times that this is the x-axis going across this way from left to right, and this is considered the y-axis. As far as the quadrants, this guy here is called quadrant 1. We use Roman numerals. This is quadrant 2. This is quadrant 3. And this is quadrant 4. IV is how you do a 4. Now, this guy here, 0, 0, is called the origin. And that's where we always start when we're graphing. Alright? We always start in the middle, and so if we have a coordinate, what we call an ordered pair, it's a point on the graph. So I'm just going to make up one here. If I said the coordinate is negative 3, 4, well, we always do the x's first. That's the x part of it, so that means I'm starting always at the middle. I'm going to the left 3, 1, 2, 3, and this y is the second number is my y coordinate. It's a positive 4, so that means go up 4. 1, 2, 3 to the left, 1, 2, 3, 4. Our graphs are getting smaller as we get into 9th grade. They don't label the x and y axis anymore for us. We should know that. And so when you're making your dots, try to make them visible, but not overly exaggerated, big. Okay, we're going to start connecting these guys tomorrow. Alright, so when we're naming points, they're ordered pairs, and so they're in parentheses, and so we go find this part over here. And so we always start in the middle, and to get to A, we go left, so that means it's a negative. 1, 2, 3, negative 3, comma, very important, there's a comma there. 1, 2, 3, 4. And that guy, if you want to write this over here, this is quadrant 1, 2, 3. We go counterclockwise. IV. 1, 2, 3, 4. So that guy is in quadrant 2. Another thing to think about is that if it's in quadrant 1, the first part of the coordinate is going to be a positive, and then the second one's going to be a positive. They're both positives in this quadrant. On this quadrant, we're going to go to the left, so the first number should be a negative, and then the second number should be a positive in quadrant 2. Down here on quadrant 3, it's going to be a negative, negative. So sometimes that's how, whoops, I don't know why I got the 1 there. On this quadrant, to get to anything in this one, the first one has to be a positive, and the second one has to be a negative because we went down. So sometimes we'll look at that, we'll practice this. Let's see, where's letter B? Right here. So my first one, better because it's in quadrant 4 down here, my first one has to be a positive, and so to get to B, I go 1, 2 to the right, and then I go down 1, 2, 3. again, very important that you put parentheses, commas, okay? Missing quadrant 4. IB, there's C. For some reason, this is the one that kids mess up a lot on, is because you're not going left or right. You start at the origin here, and it means you don't go left or right to get to C, but you go up 2. And so sometimes kids struggle with that one. They have to really think still in ninth grade. Let's see, letter D. It's right there. So I want to go 1, 2, 3, and see how it's gone up. So we have positive, positive. So I'm going to go to the right 3. Up 3, and that's in quadrant 1. Whoops, down here's 1. I didn't do 0, 2. Now when we do 0, 2 here, we say it's on the y-axis. Okay, it's not really in 1 or 2. So what we say is it's on the y-axis. So I kind of missed that one, didn't I? Here we go. Let's see, where's letter E? Right there in quadrant 3, so that means go left, 1, 2. You probably are just nailing this and waiting for me. 1, 2, 3, down 3. Sorry, I'm getting a little bit of a cold here. We had a little rain last week. Let's see, last one, F. Where is, oh, there he is, way over there. So when I go 1, 2, 3, 4, 5 to the right, and don't go up or down. And he's on the x-axis. Okay, pretty easy, I hope. Now, this is super, super, super important that you know the difference between a discrete graph and a continuous graph. I was helping a girl the other day with this in 8th grade, helping her figure out the two. And boy, was she having a hard time, even though we wrote this note. A discrete graph is a graph with distinct points. I even drew this, and I would encourage you to as well. Distinct points means it's like individual dots. It could be anywhere, but they're not connected by a line or anything, and so that's going to be a determiner when we go to write our domains and ranges today. If it's distinct points like that, discrete graphs will always have brackets like this for when I list my domains and ranges, okay? A continuous graph is a graph with connected lines. And I won't even put in curves. Who cares if it's not a straight line? And so my example over here is going to be something like, you could have a linear line, something like this, but it also could be a curved line. It's connected dots. Okay, so anything that's like that, and I'm not sure why she was having such a hard time, because I'd say, hey, here's a graph like this, it's a line. Is that a continuous graph or a discrete graph? And she'd go, continuous, discrete, discrete, continuous. She wouldn't just focus on. I think this should be a pretty easy concept. But anyhow, on the continuous graph, when we're doing domains and ranges, we're going to have inequality signs that will help us decide, because we have lots of x's and lots of y's when we do domains and ranges. Okay? And so that's where we're going next. Okay? All right. This guy's turned sideways, but I think you'll be all right. So, a relationship is a set of ordered pairs. We have lots of definition today. Now, a set of all the x values is very important. It's called domains. This will not go away. This is not something that's just one time and we just never use it in math again. My kids are starting quadratics right now and graphing, and they have to list the domains and the ranges. And so it's very important that we get these guys down. And in Algebra 2, you'll do it again. Now, I want to put a couple of extra notes here on domains and ranges that when I list them, number one, you list them in order, least to greatest. And second thing that's important, list only one time. So if it happens twice, we list it only one time. Okay, especially on discrete graphs. So here we go. I know domains are my x's. This is on my wall. Here's the other thing. You see how it's a bracket here? Domains are always listed in brackets. If they didn't write the word domain here, then you have to list domain so we know who's who. It's a bracket. And all I'm going to do is focus on my x's. I see -3, -2, 1, 3, and -3. We always list them in order from least to greatest. So as I look and scan all these numbers, I see a -3. I see it twice, but I'm only going to write it once. Then comes -2, so I'm going to put comma, -2. That guy is gone. Sometimes I'll put a check mark. And then I got a 1, and then I got a 3. Close your brackets. Let's go do my range. Range is my y's, so I'm just looking at these guys now. Sometimes I'll underline them once with a pen, and then I'll underline my ranges twice. Somehow we have to make sure we're just focusing on these guys, and I want to look for my smallest one. It's a -4, and then I got a 0. That guy's done, that guy's done. Then I got a 1, he's over here. I got a 2, and I got a 5. Close my brackets. Okay, they're not parentheses, very important. Now, when you write a table, you have to write it exactly like it is over here. Okay. Order is not too much important right here, but with ordered pairs, order matters. With mapping, order matters. Now on tables and graphs, order doesn't matter, okay? So work that out with a couple practices. Where was I over here? Oh, let's just transferring these coordinates over here to my table. This is how we're going to graph. These guys are coordinates. And let's go from the table over here to this graph. Let's just go ahead and graph these guys. You always start in the middle, so that's the origin. That first guy says go to the left 3, go up 1. 1, 2, 3, up 1. The next one says -2, 0. 1, 2, don't go up or down. 1, 1, 2. 1, 2, 3, down 4. 1, 2, 3, 4. -3, 5. He's up here. So, order doesn't matter. I want to put it here. Order doesn't. We'll just do it one. And over here, order doesn't matter. As long as we get the dots and the coordinates on the table and the graph, we're okay. But now on these two, order does matter. Okay, we always put it in least to greatest, and we list it only one time. Order matters on mapping diagrams. So on mapping diagrams, if you've forgotten, these are my x's, these are my y's. And so if you have your domain and range over here already, and you already have it in order, this makes this really easy. So -3 is my first number, -2, 1, and a 3. And then also in order, least is on the top. So you already have it in order over here. And again, you only list them once in both of these guys. Okay, so now what I like to do if I have ordered pairs here or a table, when I draw my lines, I like to just go with one of these guys, because -3 matches up to the 1, so you draw as straight of a line as you can to 1. -2 and 0 matches up. 1 and 2, he's over here. 3 and -4 matches up. And minus anybody? I got -3. Oh, -3 matches with 5 here as well. So maybe you remember this, that when we get to functions, that's not a function because I have 2 lines coming off of this guy. We're on function later on today. This is not a function if I did the vertical graph, because you see if I drew a vertical line right here, it would hit these 2 guys. So even though we're not talking about it, we can think about it, okay? All right, we don't need all these extra notes here. That's for you to look back on today. So, again, let's do this and let's try to go a little bit quicker here. I'm looking at just my domains, which is my x's. I want to put them in brackets. And I'm going to put them in order from least to greatest. Going to look at just my y's. It looks like my x's were in order, which is nice, but my y's are not in order. I got a -3, -2, I see a -1. I see 2 4s, but I'm only going to write it once. And I thought I saw a 5. No. Okay. Looks like that's it. Transfers. I want to go over here and do my mapping diagram a while, because they're already in order. -3, -2. Now when I go to these guys, I want to say -2, -3. So -2 matches up with -3. Again, I'm just copying my coordinates here. -1 matches up with 4. He's down there. Matches up with 4 right there. And my last one, 5, -1. Now when I go to functions, whether this is a function or not, and they give me a mapping diagram, I see one line coming off of each one of my x's, which is my domains, and so this guy would be a function. Every domain has only one range. I don't care that 2 of them match up with 4 over here, okay? Alright, that's coming later on. Let's go graph these guys. -2, -3. And 1, 2, -1. Alright. Alright, probably should have used a different color. Alright, sometimes they'll do this to us. They'll give us a graph, and they'll say, give me my domain and range, and make a mapping diagram. So I'm going to take my coordinates here, and I'm going to put them in my box here, because that'll make these 2 jobs a whole lot easier. That's -4. 1, 2, 3, 4. I want to put -4, -4. That guy's -2, 3. So now I can kind of go over here to each one of these guys. Let's make my brackets. I'm focusing on these guys. It looks like, because the way I did my dots, I went from left to right. These guys are already in order. So that might be something too if we have to do this. If you go from left to right, then your domains will be in order. Now my y's are not necessarily in order. You'll see that here in a second. Okay. Now let's go focus on my y's. They're here, so I'm just going to scan over here, and order again matters. I see a -5, looks like it's my smallest. So that guy's gone. I see a -4. I see a -3. Then I see a 2. And I see a 3. Alright. I got them all. Let's go make a mapping diagram. Now these two guys help each other because all my domains are in order. So again, I want to put them in order from least to greatest. There's all my ranges in order. The 8th grade teachers are finally teaching this correctly, that order matters on these two. I was very happy to see that. They were just happy before that you got the domains and didn't care too much about order. Order matters on them, okay? It'll be helpful down the road here. 0, -3 matches up. 2, 5. And 4, 2. All right. So again, we're going into functions now. This would be a function because I see only one line coming off of these guys. This one's a function because I see only one line coming off. If I go over here to the graph, and you remember the vertical line test, if I did a vertical line, no matter where that dot is, I hit only one dot. But up here, I saw one up here that was not a function. First one, if I drew a vertical line right there, bam, bam, I hit 2 dots, so that would make it not a function, okay? So that's where we're going next here. So we're going to do domains and ranges, and we're going to scan for domains. We scan from our pencil from left to right. That way everything will be in order. And X means domain. Okay, so when I do my domain, if I do it from left to right, then things are already in order, especially when I do my discrete graphs. When I do my range, I encourage you to scan from the bottom to the top. And you'll see why here in a little bit. So this is where that continuous line and discrete lines are very, very important. Remember, discrete, so we don't have to come back to our notes back there. Discrete graph is individual dots. And then continuous is a line. So this is a continuous graph. This is a continuous graph. And so when we have a continuous graph, when we usually do domains and ranges, if we have some that have a stopping point, then we have an inequality sign. But now, if we think about this, domain means my x's, and so when we start way over here on the x-axis, I start reading my x-axis from left to right, and I figure out where am I going to start hitting my graph at. And because this guy has an arrow that goes forever to the left, and this guy has an arrow that goes forever to the right, even though he's going up, as I look up and down, I will hit my graph eventually somewhere up there on the roof and into outer space. No matter where I go, I'm going to hit my graph. And even on the left side, when I go to the left here, it's going to keep hitting my graph. And so in this case, our domain is all real numbers. And if you remember back to the beginning, real numbers includes negatives, positives, and fractions. So it's all real numbers. Now my range is not all real numbers because we start at the bottom and I start my way up. And I'm looking left and right. And where do I first start hitting my graph on the y-axis? I start hitting it right there. So I know it's a y, and it just starts right there at -2. So I put -2 here, and then I hit my graph, hit my graph, hit my graph, hit my graph, and no matter how high I go to infinity, because that arrow keeps going up, I have my graph all the way to infinity. So I'm going to say y is all numbers greater than, y is greater than -2. So one boy in my class who keeps struggling about that sign there, he doesn't know how to read it. So as you read from left to right, I get to the fat part first. That means all the numbers larger than -2. Okay? So this is where that greater than, less than sign comes very important, that you know how to read them. Okay? Alright, let's see over here, my domains. So again, I start for domains. I start from the left and work my way to the right. I don't hit my graph. I'm looking up and down, so I want to put that up there. Domains, I look up and down. I go from left to right, but I'm looking up and down. So I didn't hit my graph anywhere. Didn't hit my graph anywhere. Up, I hit my graph right there. So there's where I start. Now, I have a starting point on the x-axis and I have a stopping point, meaning I don't have anything over here. So what I do is we're going to write a compound. I want to put my x automatically in the middle. And if you, just like we did with compounds, if we put them in standard form and we're looking from left to right, right there is going to be my smallest number. -1, 2, 3. So I'm going to put -3. Compounds, inequalities, if you write it in standard form, it will always be to the left. Now, I'm hitting my graph because I'm moving left to the right. I'm still hitting my graph. I hit it twice. Who cares if I'm hitting it? I'm still hitting it. And I stop hitting it right here at 1, 2, 3 as well. And so that means x is all numbers less than 3. So any numbers in between -3 and 3 on the x-axis, I'm hitting my graph. Okay. Now as I go to my y-axis, I start at the bottom and I'm looking left and right. And as I look from left to right, well, I didn't hit my axis or graph anywhere. Didn't hit my graph anywhere. Hit my graph right there at 1, 2, 3, -3. I know domain, our ranges is my y's. So y is greater than -3. So I'm going up from -3. I'm still hitting my graph, still hitting my graph, still hitting my graph. And I stop hitting my graph right there at 1, 2, 3. Now, not always are these guys the same numbers, okay? This just happened to be a centered graph here. So I'm hitting the y-axis, my range, anywhere from -3 and it stops at 3. Anywhere in between those, that's why we have a compound here, I hit my graph, okay? So again, you have to use your imagination here. There's an arrow on both ends, that's very important. So that guy goes forever to the left, this guy goes forever to the right, and when I look from left to right and I'm moving my pencil from left to right, but I'm looking up and down where I hit my graph. Well, I'd hit my graph no matter where I go to the left and to the right. I'm going to hit my graph, so this is going to be all real numbers. There's no abbreviation, okay? All right, now my range, this is kind of interesting. When I start way down here at the bottom of my graph, eventually I would hit out here because this guy goes forever. No matter how far down I start, I'm going to hit my graph. And because this guy is going forever upwards here, no matter how far I go up on my y-axis, I'm going to eventually hit my graph. So this one's going to be all real numbers. Now, here's a quadratic. This is what my kids are doing right now. So when I say domain and range isn't going to go away, we took a break for a little bit, but it's back. All right. So again, I'm going to go from left to right, but I'm looking up and down. And because this guy has an arrow and he's getting fatter, if I started my graph and I went down, eventually down here, I would hit my graph because that guy would go down here and he'd hit somewhere down here. So because he's getting fatter and fatter and fatter, no matter where I look, eventually I will hit my graph. So this guy's going to be all real numbers. Even on this side as I looked, even though I'm out here, if I came down and I come down far enough, way down here, that guy is going to hit my graph because he just gets fatter and fatter forever. Okay, so parabolas like that, our domain is always going to be all real numbers because these guys keep getting fatter. Now, when I do my range, though, I don't have anything up here. So as I move from my pencil from bottom to top, I'm looking left to right. I hit my graph, I hit my graph, I hit my graph, I hit my graph, and I keep hitting it, and I hit it here, but now I'm not hitting it here. So I'm going to have an inequality that y is all numbers, and there's where it stops hitting my graph. 1, 2, 3, 4, I believe. And I want all y's less than 4. Because it's a solid line, I want to put the or equal to sign there. So no matter how far down I go, I could come way down here and look left and right, and that graph is eventually going to hit way down here. But it has a stopping point right there at 4. So I want all numbers on the y-axis that are less than 4. Okay, so that takes a little bit of thinking there. All right. All right, you'll get better at it. Let's see here. Domains are my x's, so I want to move my pencil from left to right. And I don't hit my graph, I'm looking up and down, but there's where I first hit my graph. And I see over here that my graph stops. So what I'm going to do is automatically make a compound inequality. My x's start at -1. I hit my graph, hit my graph, hit my graph. I'm looking up and down, and I stop hitting my graph right there at 1, 2, 3, 4, 5. So I want all the x's in between. All the x's greater than, because you read from the middle to the left, greater than or equal to -1, but less than or equal to 5. So that was very important when we did inequalities that you know how to read these guys. X is greater than or equal to -1, but x is less than or equal to 5. Okay, let's go do my y's. It has a starting point right here and a stopping point. So this one's going to be a compound inequality because I have a starting point right here, moving my pencil from bottom to the top, and I first hit my graph right there at 1, 2, 3. And I keep hitting my graph, keep hitting it, keep hitting it. Who cares? It's hitting twice. And I stop hitting my graph right there at 1, 2, 3. Okay, at a positive 3. All right, got to use your noggin here. This guy goes forever down this way to infinity. So no matter where I start my pencil on the left and start moving to the right, I'm going to eventually hit my graph. And he goes up like this to forever. And so no matter how far out to the right I go, eventually I'll hit my graph. So this guy's going to be all real numbers. So you have to use your imagination of extending that line. Okay, let's go do my range. Because this guy's going forever down, no matter where I start my pencil on the bottom and start working up, I'm going to hit it. And because this guy goes forever up, no matter how high I go, I'm going to eventually hit it. So this guy's going to be all real numbers. Alright, so just have to use your imagination a little bit. Alright, we got a lot of notes here today. Here's my domain and range here. It's a continuous line, so that means I'm probably going to have an inequality sign. Do we have any discrete graphs yet? I don't think we have. Not yet. Alright, so this line goes forever down this way, so no matter how far over here on the left I start, eventually I'll hit that line. And no matter how far to the right I go, eventually I'll hit it because that guy's going up. Actually, it looks like he probably has this pattern here of going up and down. So no matter where I am out this way, I'm going to get it. Either way, I'm going to have all real numbers. Now I think they're going to say this means continuous, that it's going to come back up and down like this because I see this pattern here. Okay. So I have, as I move my pencil from the bottom to the top, I have a starting point right here. So this is going to be a compound one. I start at -1, 2, 3, -3. And I have a stopping point right here at 1, 2. I'm pretty sure that's what it meant to intend it. They probably should have put the line, like made one more curve and then made a little line like this. Okay. Alright. Getting the hang of it, I hope. Alright, domain, you move your pencil from left to right. I'm looking up and down, but I'm not hitting any graph until I hit right there. So, x starts at -1, but no matter how high I go, I'm hitting it to the right here. So I'm going to say x is all numbers greater than or equal to -1. I want all the x's more than 1. So because these arrows here go forever, it's not going to be a compound one, so this one gets a little tricky. Got to know how to read the sign. I want all x's greater than -1. This way. Alright, so this is where it gets a little tricky. My range, because this guy's getting fatter and fatter, he's eventually going to keep going down this way to infinity, and that guy's going up to infinity, so guess what? This guy's going to be all real numbers. Because no matter where I start my pencil down here, eventually I'll hit it out here, and know how high I go, eventually I'll hit it to the right there. Alright? These guys are a little bit more of a challenge too. It's still a continuous line, so chances are pretty good I won't have an inequality sign. Alright, so my domain, my pencil, I start moving from left to right. I'm not hitting the graph, but I hit it right there at 2, and only at 2. So here I want to say X, my domain is 2 and only 2. It hits at 2. I continue on, nowhere else does it hit. Okay, it's a vertical line. So now my range though, no matter how far down in the bottom I start and going up, I'm always going to hit my graph. So this is going to be all real numbers. Over here, I got a horizontal line. So no matter where I start over here with my pencil, I'm going to look up and down, and I'm going to always hit my graph, because that guy goes forever this way and goes forever that way. So as I move my pencil from left to right, I'm always going to hit that guy. So he's going to be all real numbers. And now let's go to my range. I start down here and I move my pencil up. Well, I didn't hit it. I hit it right there at -1, 2, 3, 4. And I only hit it at 4. So it's not an inequality sign, because the only place I hit on the y-axis is 4. No matter how high I go, I'm never going to hit that graph ever again. Okay? So just a little bit of thinking needs to be involved here, but I think you can handle it. You did it in earlier grades. Alright, here we go. What is a function now? Let's do this guy here. A function is a relationship where every domain has one and only one range. And so if they ever asked us, why is it a function? And if it's a function, that's what we're going to say. Every domain has only one and one range. So again, functions, when they give us coordinates like this, let's see up here. Oh yeah, let's highlight this. X, so all I care about is my X values. And if the X values repeat, then it's not a function. So if I have more than one X value repeated, then it's not a function. But if the X only happens once, then it's a function. So I'm going to put that, if only one time equals a function. If they told me to explain, which today I don't think they do, you would say every domain has one range. Okay? And then if they give me a graph, I'm going to do the vertical line test, which kids are good at this one. They remember that one from earlier years. Okay? So let's decide if this is a function or not. All I'm going to do is I'm going to circle my X's here. That's all I care about. And as I'm going across, I'm looking for any time that one of these guys might be repeated. I don't see any repeated, so this is a function. Every domain has one and only one range. Over here I see a -2, I see a 0, a 2, a 3, and a 2. I have two 2's right there. So this is not a function. Earlier this year when you did it, you had to say why it was not a function, and we would say the domain of 2 has two ranges, -4 and 4. Okay, so right now we're starting with the super easy one, or easier ones, and we don't have to explain it. Okay, they didn't say explain. Alright, again, I don't care about my y's, all I'm going is my x's here. I see two -3's right there, so this is not a function. I don't see anything that repeats there, so this is a function. So not, but it's a lot of review from junior high. I'm getting you ready for today, or for the rest of this week and next week. Okay, so here we are. I got a 3 right there and a 3 right there. So again, all I care about is my x's. I'm not even going to focus on this row. So this guy's not a function. I'm focusing on this row. -4, -2, 1, 2, 5. This guy's a function. Every domain has one and only one range. This guy, looks to me like he is a function as well. Okay. So these guys go fast, huh? Oh, I see 2 4s, so this is not a function. Now on a mapping diagram, all I focus on is the first bubble because these are my x's. And so I don't even look at the numbers. If I see only one line coming off of these guys, then this is a function. Here's my x's. They even labeled it for us. You see how that guy has 2 right there? That's a -1 would be matched up with 0, and -1 would be matched up with the 7. So right away, I know this is not a function. I don't even have to look. Make coordinates out of function, out of those guys. So this is kind of pretty quick and easy. This is where the vertical line test comes in. So wherever I see a dot, I look up and down and draw a line. Nope, only one time I'd hit a dot, only one time there, but look here. If I drew a line, a vertical line going up and down here, I would hit 2 dots. That means 2 points is on the same chord for my domain, so this is not a function. You could say it doesn't pass the vertical line test if they give you a graph and ask you to explain. I look at my dots here, nothing's above any or below any one of them, so it's a function. That's how easy it is. Right there, not good. Don't matter that all these guys have 1s. If it breaks the rule one time, anywhere, it's not a function. Those are all discrete graphs. That's a mapping diagram, that's a table. Still asking us about a function, but now we have a continuous line. This is really easy because no matter where I draw a line, I'm going to hit my graph 2 times. I hit 2 times, so this is definitely not a function. Doesn't pass the vertical line test. If they give you a graph, you can say that. Now on this guy, no matter where I am, even though he starts and stops somewhere, I only hit my graph 1 time as I draw my vertical line. So this guy's a function. And this guy's a function, even though he's a curvy line. No matter where I draw a vertical line, and I try to break the rule, is there anywhere where I can draw a vertical line that would hit twice? No matter where I do, it can only hit 1 time. So this guy's a function. Alright, I think we're getting kind of close to the end here. Yep, that was the end. Alright, so that's a lot of review today from previous years to get us rolling on functions here. Alright, so do that homework. It should go pretty quick. Use your notes, domain and range, on when you have to list them in brackets here, and mapping diagram. Order matters. It's listed only 1 time from least to greatest. Okay? Alright, have a good day.